The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Welcome to everybody that's joining for the first time. Welcome back for those that joined last week. So this is a 5-part series of Server Tech PowerTips Live. We have various guests here that are going to walk us through some of the demos. My name is Jawahar. I'm the innovation lead at Legrand's Data Center Power and Control Division. So why we are here? So let's talk about that. As you see, I'm streaming live from my own backyard paradise because my kids kicked me out of my own office. And I'm sure many of you are facing something similar. So we were wondering how you're all handling your day jobs now that we are all doing everything from remote. So we thought we have all these remote capabilities that customers invested in. How are they using it? Let's have some time to chat with them and share some of the tips and tricks that we can do to best utilize all the features and functionality you have. So joining us today is Joel Bryan. He's our head of technical support globally, and he's going to introduce today's topic and today's speaker. Joel?
All right, thank you, Javi. As Jawahar said, my name is Joel Bryan, and I'm the Global Director of Post-Sale Support and Documentation here at Legrand for the Raritan and the ServerTech brands. So today's session is going to focus on how we avoid overloading our phases within a PDU. And walking us through this session will be Bruce O'Clair, who is our post-sale support product specialist as part of our technical support organization. Bruce is based in Reno, where our ServerTech head office is. Following the walkthrough, as Jawahar said, we will open up for questions pertaining to this particular function and feature. And in addition, feel free to add comments or type comments as we go along. And if you have questions, you could also type ahead of this session as well. For any pressing issues, as usual, outside of the scope of this, it's always best to email us at support@servertech.com. Or if you want to talk to a live person, definitely pick up the phone and give us a call. We're here. We're waiting, and we're definitely going to be trying to resolve your issues as quickly as possible. So with that being said, I'm going to hand it over to Bruce, and Bruce is going to take us through. All right, Bruce, it's in your court.
All good. Welcome, everyone. The topic today is how to avoid overloading phases, and by that it's really overloading any overcurrent protector in your system. The topic last week was how to ensure you are receiving alerts on critical events, which demonstrated how to verify you're getting notifications by SNMP, email, syslog. And so today's topic follows nicely. Today we will discuss how to remotely identify amperage capacity for a specific PDU. We will learn how to view the real-time current, the amperage measurements at various points in the system, and how to set amperage thresholds to receive alerts if an overcurrent protector is in jeopardy of being overloaded. So let's get started. I'm going to log in at administrator level to a standalone PDU in the ServerTech Tech Support Lab. I did log in at administrator level, as you can see in the upper left-hand corner. And before I continue, please note that these PowerTips live sessions, they are tailored for Server Technologies Pro 2 PDU series. The Pro 2 series measures literally everything there is to measure, with the only option being whether or not the measurements extend all the way to the individual outlet level. If your PDU is a Pro 1 type, if you see Pro 1 in the upper left-hand corner, some of the screenshots you'll see today may not apply. So I'm logged in. This is the overview page. The first thing I'd like to point out is that you can immediately see on this intro page whether or not you have an issue. I have gone off and set some thresholds intentionally very low so that we can in fact see an example of what a warning message for high currents, and that is on line status. And I've also created a situation where we see a high alarm for branch status. So you can immediately upon logging in, you'll be able to identify whether or not there's an issue, but that of course depends on you having thresholds set appropriately. So to see more information, we want to use the monitoring page. So I'm going to click on monitoring. The monitoring page identifies more information, usually through what I call the system hierarchy links, which is this section right here on the left, starting with units, which is the PDU itself. Cords is the number of cords entering the PDU. Lines is the number of current carrying conductors within that cord. And then it goes on from there. Of this list, the important things relative to today's topic will be lines and branches. And those are the two that the values that we'll look at and the thresholds we'll set are related to what are capable of causing an overcurrent protector, whether that be your upstream circuit breaker or a circuit breaker or fuse in the PDU. Those are what relate to possibly tripping those overcurrent protectors and causing an outage. So we're going to start by looking at lines. Okay. The first thing to note is that this shows you, this is where you can learn the current carrying capacity for the PDU that you've logged into. A three-phase PDU has 3 lines. So this is a 3-phase PDU. We've got L1, 2, and 3. And a single-phase PDU would have just 1 line. So we are looking at a 3-phase PDU, and we have identified that the capacity of each line on that PDU is 30 amps. Now this is the maximum capacity supported. It is also what matches the trip amp rating, or should match the trip amp rating of your own upstream overcurrent protection. That is the protection for the circuit that the PDU is plugged into. So the line current directly relates to the current passing through each pole of your own upstream overcurrent protector. And it is, what we're looking at is maximum value. Now in North America, I'm sure many of you are aware that we are only allowed to use a circuit continuously at 80% of maximum. So as we'll see when we take a look at some thresholds, the thresholds are actually not the maximum value. It's also recommended, though not necessarily mandated, that you use only 80% outside of North America, but it is typically recommended as best practice. So, this same page also shows you the true real-time measured current. Now this is a PDU in the support lab that has very few devices attached, so I am not in jeopardy at all. Again, this is just false, the one that is flashing an alarm. I am not in jeopardy of overloading an upstream circuit breaker. One additional note is that if you are practicing redundancy, you need to think about a half capacity rule. And we'll get into that next when we take a look at where you set the thresholds. Okay, for setting thresholds, you need to go to configuration. And then we're looking for line thresholds, so we're going to click on lines. Okay, for those of you that attended last week, the initial page that comes up, over on the right, this is where you can choose whether or not events relative to line current will notify you by SMP trap or email. What we want to click on next is the line current thresholds. And now we're looking at the web page where you can configure the thresholds for each line. Again, this is a 3-phase PDU, so we have 3 lines to look at. These examples are the defaults for at least for line 1 and 2. The product will default to having a high alarm value of 24 amps or 80% of the rating that we identified earlier. It was a 30 amp per line capacity, so the default high alarm value is 24 amps, 80%, and we've chosen 70%, 21 amps in this case, as the default threshold for a warning. You can see here I previously set that one surprisingly low to generate that false alarm. Anyhow, with respect to a standalone PDU, that is a PDU servicing single power supply devices, no redundancy. These values in this case with a 30 amp PDU, these values typically don't need to be changed. However, if you are using 2 PDUs per cabinet and multiple or dual supply gear, servers and switches and routers, and you are practicing an N+N redundancy system, you do need to consider changing these values to half. That is, you would consider changing the high alarm down to 12 amps and the high warning to 10.5 amps. That is for the contingency that if one of the 2 PDUs were to be powered off, to go down either intentionally or during maintenance, the failover current to the remaining live PDU would still be well under 24 amps, and you would not be in a territory where you're jeopardizing tripping the upstream circuit breaker. So line current relates to current that is passing through the pole or poles of your upstream overcurrent protector, and it must be watched to avoid overloading that circuit. One note, typically in North America, if one line is overloaded, all 3 lines by the upstream overcurrent protector are interrupted. So it would take down the entire PDU. So you need to make sure that no one of any of the 3 lines in a 3-phase PDU exceeds that limit. Okay. So now we know the limits for line currents, and we know how to set those thresholds. Let's take a look at the other item, which is branch current. I'm going to go back to monitoring first and take a look at branches. Branches, in the simplest sense, is the current passing through each circuit breaker that is built into the PDU. We call those overcurrent protectors, which you'll see over here on the left, but the branches is where we will find the current reading as well as the status and current capacity. All of the server technology alternating current Pro 2 products utilize circuit breakers that are rated for 16 amps continuous and 20 amps maximum. We can see that in this section over here. Each breaker is 20 amps. That is the trip rating for the breaker, or the trip amp value for the breaker. The rating is 16 amps continuous. And down here in the left, we see the values today are well under what is required to avoid tripping a circuit breaker in the PDU. So let's take a look at how you set the thresholds for the branches. Because if you do get into a territory where you're getting close to the limit, you will want to be notified. You need to go to configuration, and we'll take a look at branches. Similar to earlier, you can choose to whether or not to be notified by SNMP or email. And then we can take a look at branch current thresholds. And branch current thresholds, similar to the thresholds for the line current. The default values are 80% of maximum. So in this case, maximum was 20. We have a default threshold of 16 amps for the high alarm. And for the high warning, we have a default threshold of 14 amps, that is 70%. Again, this is because I changed this threshold intentionally to be very low so we would see the alarm on the overview page. Now, similar to with line current values, if you are practicing redundancy with dual supply gear in N+N environment, you need to consider changing these values by cutting them in half. So you would typically change the high alarm to be 8 amps. You would change the high warning to be 7 amps. And this is specifically for the contingency that if a source goes down and one of the 2 PDUs goes off, that the failover current not only is okay with respect to line current, but also well under the limit for tripping a circuit breaker in the PDU. Equally as important, less devices would be affected potentially versus the upstream breaker, but the purpose here is to avoid losing any equipment at all. So I can give you a sort of better example as to what I mean by the branch current. We do in technical support, we occasionally get calls where it becomes obvious that the user did a very good job at balancing their loads, so that is plugging in their different devices to appropriately balance the line current, but they've made some mistakes with respect to attaching devices to properly balance the loads across the branches. So this is an example of a 60 amp 3-phase PDU. It is what we call an alternate phase product, so we have different colors for each outlet repeating. Line 1, line 2, I'm over on the right, goes line 1, line 2, line 3, and then repeats all the way through and continues on the lower branch of outlets. A typical mistake is that an installer will start either top to bottom or bottom to top and just simply plug things in that order. And that is where you can enter a situation where your branch currents are exceeding the limits. You'll identify that using the tools that we just discussed, logging into the web interface and looking at the various values. But as you can see, the upper set of outlets has 3 circuit breakers, and the lower set of outlets has 3 circuit breakers as well. So proper installation would not be plugging things in top to bottom or bottom to top, but rather starting with outlet number 1, 2, and 3 on the upper branches, and then going to outlets 1, 2, and 3 on the lower branches, equally dividing the loads not only across the lines, but across the branch circuit breakers so as to avoid tripping one of the breakers in the PDU. So in conclusion, you must monitor both line current to avoid tripping the upstream breaker, and you need to monitor branch current specifically to avoid overloading a circuit breaker in the PDU. And with that, I will pass it back to Joel.
Okay, great. Thank you, Bruce. That was excellent. So what we're going to do is we're going to unmute everybody and give you the opportunity to ask questions. I do ask that you also check your personal device, make sure that you're unmuted there as well. So I am going to unmute and open up for questions.
Joel, I don't see any questions on the chat yet, so I'm monitoring it here.
Okay.
While we give people a couple of minutes to get that going, why don't you tell us more about your shirt? Well,
in New Jersey, it's kind of dreary today, and I guess I wanted a Hawaiian island vibe.
It's working.
Okay, good. My shirt matches your backyard for sure. One thing, Bruce, maybe you can help a little bit. Is it common that we get customers that will receive a PDU and start plugging in from top to bottom?
If they have not been fully informed, it has occurred, yes. The advantage of a product that has the alt phase feature, where we rotate those lines, line 1, 2, 3, and repeat, is that it does simplify your installation, allows you to use shorter cords from the PDUs to the equipment, creating a cleaner environment, better airflow. But you do have to pay attention to balancing between all the available circuit breakers. So proper, as I attempted to define earlier, would be to plug things in at the top. Now you don't have to go 3 at the top and then 3 in the lower half. You can just load the top, the upper half of the unit, the first 3 branches. You would pay attention to loading those until you get to half of the line capacity. Or actually a quarter in a redundant environment, then you would move on to the lower branch and use only those. It does occur. It's sometimes misunderstood. Typically it's going to be when it's a repeating install of just the same equipment top to the bottom of the cabinet, whether that be 36 or 42 pizza box servers, if people uses that term anymore. But yeah, 42 one-use servers or less, the tendency would be to just plug them in top to bottom, and it needs to be done differently. You need to pay attention to balancing between the branches as well as the lines. So it might be difficult to deal with at this point if we're all working from home, but at least you have the ability with what we've learned today to log into the PDUs to see if you are in a situation where you have risk of tripping a breaker, either upstream or in the PDU.
Okay, good. Thank you. Javi, do you see any questions coming in?
Yeah, I see a couple. So the first one is, the question is, with redundant power in the cabinet, is there a way to set alerts between shared PDUs, since one PDU may be higher than the other?
Okay, so let me understand, does that mean you've got a PDU of one capacity and another PDU that has a different capacity?
So hi, sorry, this is Chris from 5.9. Just to clarify my question, we have certain equipment that draws more power from, let's say, the A side versus the B side. So we'd have the same PDUs in the cabinet. However, if we set our alerts to half with 7 and 8 respectively, if one PDU, let's say, runs at 10 and the other one at 3 or 4, is there a possibility to set alerts based on the two in conjunction with each other?
Well, yes. I mean, you would have to do it manually. There's no magic button that will just read the values and then adjust on the fly. You would have to look at those values first and then go set those thresholds appropriately. I could log in the Pro Series PDUs have the ability to have up to 4 PDUs exist through a single unified interface. Most commonly is one master PDU and one link PDU, so 2 PDUs per cabinet. In that situation, you'd be looking at a single interface that would show if it was 2 3-phase PDUs, where we looked at lines, you would actually end up seeing 6 of them. These ones are identified as AA1 through 3. If there was a link unit attached, you would see a BA 1, 2, and 3. And then so you'd see it all on the same screen, and then you could simply jump to the threshold configuration page, again in the configuration section, to set those values accordingly. You'd have to take a look ahead of time, make sure that the sum of the 2 different values does not exceed. If it's a line, in this case, you'd not exceed 24 in the example on the screen. And if it was a branch, you would need to make sure, which I think is what you were talking about, if you had different values on the A and the B outlets, because the device doesn't equally balance the loads, you would look at those loads, set the individual thresholds accordingly, but make sure that the sum of the 2 doesn't exceed 16.
Okay, and Chris, if you need maybe Bruce to maybe walk you through, we can certainly set that up following this call as well.
Okay, sounds good. Yeah, we have various distribution of master and linked, and mostly they're master and master in the cabinets. And we put in a request to see if you can link 2 masters together, and I know it's not right now, but
okay.
Yeah, I know it's possible to do it manually. Just wondering if it's possible to do it together, since they're both in one cabinet.
Right. Okay.
Right. One of the options for you may be something about the PDUs. So something like a PowerIQ software that can give you management and alerting capabilities, not just at the PDU level, but a couple of elevations above. So you can set alerts for a rack or a row or a pod, or even at a data center level. So if you already have PowerIQ, that's the place you would do it. If not, that's another option that you can consider.
Okay, sounds good. Thank you.
Okay, Javi, what else do we have?
So I see another question. This may need a little bit clarification, so please feel free to jump in. the question is, I have an AA4 and an AAN line. What is that? So that is the question. So Bruce, if you know what it is,
Sure.
if not, we can ask.
Yeah, right. And I did not use that type of PDU for my demo. I've logged into a North American PDU modeled in what's called a delta fashion, where all of the outlets are wired with 2 hot lines. What you're seeing is a PDU that is a 3-phase Y, a WYE. That means that 3-phase PDU contains 3 hot lines at the input, a neutral, and a ground. And in that case, all of the outlets are wired line to neutral. And the N is your neutral. So with those products, the 3-phase Y products, we do actually measure current on the neutral conductor. That doesn't relate to overloading any overcurrent protectors, however. Even if you are as far out of balance as possible with respect to your 3 phases, you cannot create a situation where the neutral gets overloaded. So it's an informational piece only. There is, with that type of product, a YPDU, there is benefit to balancing your loads. The better balance, the lower that neutral current value. So you're more efficient. You're not wasting energy as heat through the neutral conductor if you're able to balance your loads. Out of balance, the neutral current goes up. In balance, it goes down. So it is informational. It just gives you a quick idea of how much current is flowing on the neutral. And separately, with the PDU actually does have a feature where it can notify you on out of balance. We have a feature that can be enabled that will tell you if you're out of balance beyond a certain percentage and alert you on that. It's not an issue necessarily, but it just is an indicator that you could potentially do a better job balancing and be a little bit more efficient. And out of the box, the default for that is 20%. So if out of the box your lines are out of balance more than 20%, we have the ability to notify you of that. And it's effectively what you just described. It's that neutral conductor being out of balance results in neutral or current occurring on the neutral, which if possible, all depending upon your equipment, if possible, then you could balance those connections better, moving power cords around. If you get that down to 0, you're more efficient.
Okay. Great.
All right. Thank you, Bruce. So we do have 2 other questions. Let me see. So the first one, it says, I get 3-phase errors at times. What does that mean?
3-phase errors. Well, I would need to know more about exactly what error. Is it an out of balance error?
Yeah, Bill, if Bill's still on, if you could unmute and maybe add some.
So the answer is yes.
Okay. So this probably
your question is, yeah.
Go ahead, Javi.
Yeah. So Bruce, the answer came back as yes to your question, which was is it out of balance error?
Right. Okay. Well, yeah. So there's 2 ways to approach that. Ideally, you'd be looking to try and identify the individual loads of everything plugged into individual outlets, where if we're still looking at the screen, this per outlet power sensing feature. If your PDU contains per outlet power sensing, you can review the current for each and every device related to which phase it's plugged into, and you can look to see, is it possible to move power cords around to balance out the phases to have a more balanced system. So that's the ideal objective, is to attempt to reorganize where things are plugged in to balance the loads and therefore not get those alerts anymore. But if you just want to avoid getting those alerts, you can change the percentage or disable. And I'm actually searching. I haven't looked for that feature for a while, but it is here. It is here somewhere. Because the default is 20%. You could simply up that percentage. And I do have the formula. If you want to contact me after this session, I can send you the actual formula that we use for determining the percentage of out of balance. But those are the two choices: either disable the notification or change that percentage from 20%, the default, to something greater, or ideally attempt to reorganize where things are plugged in to actually achieve better balancing. But that is just it's not really a warning per se, it's just a courtesy notice effectively. If it's an out of balance error, there's no real error to it. It's just an indicator that if you could do better, you should try.
Thank you, Bruce.
I'm going to keep.
We do have the contact information, so we can follow up on the topic.
Yeah.
So I do have one other question on the line. The question is, this is off topic, but how do you copy and paste the values from one CDU to another? Is this being pushed? And the further clarification on that is, this is for the line settings and the thresholds.
Okay. I think that's going to be one of the topics next week, so I'd invite you to come back. But the short answer, well, there's several different ways, but the short answer, if we're talking Pro 2 again, if you're still looking at the screen, logged in at administrator level, you can go to configuration and files, and then the config.ini, there is what we call a stick protocol. That's short for server technology INI configuration. So we do have a very powerful INI system built into the Pro 2 PDUs. So config.ini is what you would grab out of one PDU, and then you can push these values to other PDUs, not entirety. You can simply cut out sections that you want, create a text file simply, for example, for thresholds, and then you could push that file to the other PDU. A great document to look at would be to go to the ServerTech website, hover over the word support, go to firmware downloads, click on it, really doesn't matter, switched or smart, it's the same with Pro. And this item over here on the right, stick documentation. Again, stick is short for server technology INI configuration. That document will go into details about how to use the INI file. That would be one of the simplest ways to replicate a configuration, either in full or in part, between one PDU and another. And if you'd like some assistance with that, yeah, just reach out to our support department at any time.
Okay, great. Thank you, Bruce. Good, valuable information and great questions from the audience as well.
I believe we have answered all the questions that were on the line, at least the ones that I saw. Let me take a look one more time. Okay, there's one follow-up question. How did you get that power history graph on the main page?
Yeah, so somebody else set this up and enabled it. I believe that will be found. No, configuration network. Configuration network. I believe it is in the email page. Yeah, there you go. So trend files. So you need to go to configuration network and then email/SMTP. And this option here, trend files, serves two purposes. One is that it will start writing some CSV files that you can get from the PDU that have trend data. And the other is that it enables, oh, actually, that one's disabled. I thought that was it, was that you had to enable that option, and that brought up the trend screen.
And configurations, trending.
Thank you, that was Indika, I believe. My apologies, and thank you, Indika.
Sure.
There it is, yeah. So configuration trending, and click that box, click apply, but realize that you're not going to see something for a while. It's going to take a while for the data to exist, for the graph to start showing you things.
Okay, great. Thank you. Thank you, Bruce. Thank you, Indika, for chiming in as well.
All right, at this point, that's all the questions that I see. If anybody have any final questions that you would like to ask by voice, please do so now. If not, we can wrap this up.
Yeah, so again, thank you everybody for joining us. We'll be doing this again next Thursday, which we'll promote and we'll put information on LinkedIn, and you may possibly get a mailer as well as a reminder to join us for the same time next week and the following weeks as we go through some of these important power tips to help you and your infrastructure during these times. Okay, thank you, and Jawahar and I are going to trade shirts next week. Yours will be a little bit small on me though. But
If
thank
anybody
you,
is
everybody.
happens to be watching still, I found it. Apologies, I should have known where it was, as with the trending. But yeah, the three-phase out of balance that I mentioned feature is found on the configuration system cords page. And
Boards. Okay.
Okay, great. Thank you, Bruce. Thank you, everybody.
Thanks again, Bruce. Thanks, everybody. We'll see
thank
you all
you.
next week.
Bye.
Thank you all.
Thank you.